today we're going to do some 8s and 7s. So we're going to do this. Whoa. So some new animals have arrived at the zoo. The zookeeper is concerned. Correct the broken point to make sure that the second argument tail is the same as the last letter of the first argument body. Otherwise the tail wouldn't fit. Okay. So what's happening here, let's go ahead and read this function. Correct tail is taken in a body and is taken in a tail. And it's saying that, hey, body substring of this length of body. So we're just going to grab the substring of the entire body minus the end of the tail. This one closes this one, so you need to close this parentheses. If sub is equal to tie, this will be tail. This one right here is saying that I'm assigning you to equal to this, but we want to check. So if we want to check, we need 2 equals. And also in Python, it matters about indentation. So this one will be here, and this one will be here, else. Return false. Indentation matters. Body dot substring. I don't know if we even need a substring like that. No attribute substring. Substar Python. Yeah, I was like, I've never seen substar. Substring st. Yeah, the beauty of Python is the power of slicing. So it would be body. We're gonna grab the last one. We're just gonna select. Oh, that's gonna reverse. So if you want to grab the last one, minus 1. Yeah. Because the reason why I did it as -1 right here, it's grabbing the last one. We're going to include that and everything after that. So it's just going to include just the last letter. We can even make this into ternary. Return true is the last one is equal to tail, else false. That is true. Because this is going to check it already. Oh, you're right. If body minus 1 is equal to tail. Because that would return true or false already based on checking. Something in my eyeballs. Yeah, okay, so there's no such thing as a substring method. I did think that was weird for Python. I was like, I've never seen one. Sorry, hold up. We're back, baby. Okay, we're gonna fade this out. So, find the total sum of internal angles and degrees in an n-sided object. An n-sided simple polygon, n will be greater than 2. 180. So, okay. So receive an integer. We need to return sum of internal angles in degrees in a polygon. N will always be greater than 2. 180 divided by 3. What's 180 divided by 3? 3 goes into 6 times 3. 6 times 3 is 18. 6 times 3. Yep. So this is 60 degrees. 4. I'm going to play off of the examples. We're going to play off of the examples and we're going to figure out, hey, how did they get based off? We're going to play off of the examples and we're going to look at their answers, see how they got their output from the inputs they received. From there, I'll be able to determine how they got to where they are. I know nothing about polygons. I know nothing about angles. Didn't do so well in math class, especially with shapes. 4, so 360 divided by 4. I'm playing around. Do I divide? Do I multiply? 360 divided by 4. So 4. I think there's a rule here that we should know about polygons first. 360 divided by 4. 4 goes into 36, 90, so it's 9. 36 divided by 4 is 9. So, I'm trying to think. So it seems like every time you go up, you add 30 to it. That's what I'm thinking. Because you can see the difference right here. There's a 30. And inside a polygon. Every time you go up is 30. So 1 is, because I'm thinking 1 is equal to 30. 2 is equal to 60 divided by 3 is 20. 20, 20. And then move it to 3, 60. But it's 60, 60, 60. And then now it's 90. So 2 would have been 60, 60, 60. 180 divided by 3. 180 divided. Find the total sum of internal angles in degrees. Going back to my math class days, you could think about degrees, angles, 45, 30. I feel like angles can be any number though. I was like, can I base it off of a number? If I base it off of 30, why do I want to base it off of 30? Find the total sum of internal angles in degrees. Polygons. So that means that each side was 60, so they're all going to be equal. 60 times 60, or sorry, plus. And then how do I get to the 60? 60, 90 plus 90 plus 90. So this one would have to be 30. 30, and we're going to add another 30, which gets us to 30. That would get us to 60. 30 plus 30 gets us to 60. 30 plus 30 is equal to 60. Anybody know the rules of polygons? Let me know. 30 plus 30s, 30 plus 30s. So then 5s. So 30 plus 30, and then you plus another 30, which is a 90, and 90 plus 30. So this would be 120. 120. 30 times n. Can I do 30s times n? No, because 30 times 3 is 90, right? 30 times 3. 30 times 3, 90. Okay. Return n times 30. This should pass. Or 60. N times 60, yes. Okay. So something about dividing. We're going to say that it's in multiples of 30s. If I can... Okay, so... it's in multiples of 30s. And you see how I divided the output time divided by that. And we found the 60. And then this one right here is equal to 90. Yes. Okay, so for every, we're gonna, okay, the way I think about it, okay, so iterate up to n, keep adding 30 to the total, then return the total times n. So we're gonna say the total is equal to 0 for a num in range of n. We're gonna go up through n, and we're gonna say total plus equal 30. Then we're gonna return total times num. Yes. It's a high five chat. So this is the way I'm thinking about it. I feel like there's a simpler way to simplify this. For num in range of n, total plus equal 30, total plus equal 30. This will definitely be time complexity be O of n, because we had to iterate up to each number up to that n amount. Space wise, it's just a number that we're returning back, so it's gonna be O of 1 constant space. I am gonna go with this. Okay. Dun, 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 dun. Okay, we'll figure this out. N 1680 should equal to, okay, 5, example 6, plus another 30, 150, example 7, okay, so 5 should equal 140, 5 times 120, 5 times 120, 120, 5 times 120, 600. So 600 should equal 540. 540. Okay, so you're saying this should equal 540 divided by 5. What's 540 divided by 5? 540 divided by 5. 108. So you're equal to 108. Somewhere along the way, 4 is equal to 90 because we did the math up here. And now 4 is equal to 90. 540, 90 minus 108. 108 minus 90, 18. It only went up 18. Maybe there's something about a polygon. Ooh, okay, so instead of doing total, I could use the sum function. I forgot I could do that. So we will do that in a bit. Oh, it's n minus 2 times the 180. I would have never guessed it. I thought I did that right. N minus 2. Okay, let's play that out. N minus 2 times 180. We'll put in 3. Let's do 3. Example is 3. N minus 2. Formula is n minus 2 divided by minus 1 or plus n times 2 minus 1 times 180. That's right. I I see. Okay, because yes, this one is saying that for 3, it's 3 minus 2, which is 1, and 1 times 180 is equal to 180. Oh, see, matey. So we're going to return n minus 2 divided by 1 times 180. Oh, it's that extra other formula you have to figure out about polygons. I almost thought I figured it out, but okay. Be right back later. I hope to catch you later this afternoon. Have a great rest of your day.